Okay, so here's today's quiz, quiz 1B. First question, the definition of a function. Complete the following using the definition. Let x and y be sets. Let f be a collection of ordered pairs from x cross y. F is a function if. This is the answer I want. For every x in x, there exists a y in y so that xy is in f. And if x1, y1, and x2, y2 are distinct points in f, then x1 does not equal x2. Colloquially, this is every x gets used and no x gets used more than once. Okay, so I always get the question, do I want that answer? And the answer is yes. If I give you a definition to memorize, I want it back. Now, if you have another definition that's good, right? If you're like, oh, I want to use the book's definition, most of the time that's okay, but I will tell you when it is. Assume that what I want, though, is the definition back verbatim. There are a couple of equivalent ways to say this, and if you say it correctly, equivalently, I'm fine with that. But the book's definition for a function is actually crap, because it doesn't include one of the conditions, and when it says it poorly. Okay, so if you wrote what is in orange, that's partial credit. It's a good part of the credit. It means you understand the concept. But when I do kick these definitions up, and when I do statements of theorems, I kind of want them back verbatim or close to verbatim or something equivalent to the statement. Now, again, if you did the things in orange, you're going to get 3 out of 4. It's not perfect, but it's good. Because it is a sufficiently good explanation of what a function is. And I'm very happy about that. But when it comes to definitions and the statements of theorems, you really need to get them verbatim. And that's something that you probably never had to do in a math class before. That's new. And yes, you can retake. So quizzes can be retaken for half credit, half the points you missed. And for the first quiz, and really the second one, for the first week, I'm going to give full point retakes. After the first week, it's going to be half point retakes. But I do want you to get used to this idea that there are things that I have to memorize because it's weird. You're not used to doing this in a math class, and I know that. This is something new. And I want you to get it wrong here and not on the test because what happened last semester, the semester before, the semester before, the semester before that, is some sections they don't do this on the quizzes, and then all of a sudden they lose tons of points on the test. I'd rather you lose points on a quiz than points on the test. Are there any questions about that? I know that's new. I know that's extreme. It's not extreme. It's standard, but it's new. It's new for you to be doing this. Quiz 1B. That's a good question. The process for starting one of these, doing the retake is that we have to set up the rubric beforehand. So basically we have to start grading them before we do, because in GradeScope, it's if you copy an assignment, it copies the rubric. So we want to have the rubric started. So it'll probably be a day or two before I get the retake set up. Okay. Yeah, and so the Canvas GradeScope thing, it'll be just like there. You'll see a Quiz 1B retake. I think that's how we decided to do it. All right. So where do I get these notes? Where do I get these definitions? Well, you can get them, the good definitions, you can get them from two places. One, the lectures. And two, if you go back home, remember that there's this thing here where I have class notes, suggested problems, and supplemental videos. And if you go here to week class 1A, a new perspective, you will see the official class notes, the ones that I did out. There's the definition of rational numbers, by the way. There's the definition of what I mean by an ordered pair. And there it is, right there, in red. F is a function if for every x in x, there's a y in y, so that xy is in f, and if x1 and y, if x1, y1, and x2, y2 are distinct points in f, then x1 does not equal x2. And there's a bunch of equivalent statements to that. You can have y1 does not equal y2 implies x1 does not equal x2, and all of those things. And of course, the second condition is known as the vertical line test. So how do we feel about that 1 to 5 here? Let's see. 1, 2, 3, 4, 5. So how do we feel about that 1 to 5? Okay, and as I said, it's going to take a couple times. I want you to make mistakes on quizzes, not on tests. All right. I'm going to go ahead and close this poll. And if you want to talk exactly about this, if you want to protest the fact that you have to memorize definitions in a math class, I will be happy to sympathize with you. I will be happy to talk it out with you and all of these things and explain the reasoning. I will be happy to do that. This is one of the things, a lot of times if you present a good argument, I change my mind. And I am flexible in the face of very good arguments. You're not going to change my mind, but I will be happy to listen to your complaints and kind of let you vet and all of those things. Because I know it's frustrating and it's the first time you've ever done this. All right, this is something that, a couple years ago we decided we wanted to up the standards on calculus because people were getting into harder classes and they didn't know how to do a definition. They didn't know how to do all these other things. So it became a real issue in the upper level classes. So they want us to start here, which is a good idea. It's a good thing to do. All right, so somebody give me a function here from x to y. Oops, what, purple. How many people got that one? Perfectly good function. What else do we have here? Others that work. What else works? F of x for all x in x. F of x equals a is a perfectly good function. That would be the function f of x equals 1, not a. That would be the function, that would be the set of ordered pairs A1, B1. You could have done something like this. A, B, 1, 2, and you could have done this. That's a perfectly good function. How do we feel about just getting a function, 1 to 5? Let's see. Why can't it just use the... Who knows? Now, yeah, I'll talk about the round brackets in a moment. I think I addressed them in the class. If you use round brackets, I'm not going to penalize you as long as your meaning is unambiguous. And if you did it in this context, your meaning is unambiguous. I don't like the round brackets personally. Yes, so the purple answer is correct. These are alternatives. All of which are correct. Let's put alternatives in a different color. We'll put the alternatives in green. So let's see. Let's stop this poll. Question about the tests. Yes, the tests are set up just like the quizzes. In fact, when I write the tests, I'm not writing them this year, but for the previous semesters, I wrote them. I kind of took quiz questions and I just made them test questions. And that's probably going to be similar this time, except that we have a committee thing writing the test this time. So I'm submitting questions, everybody's submitting questions. It's going to be all crazy until we figure out it doesn't work, and then we go back to the old way of doing it. But, for the moment, but yes, it's very similar to the quiz questions. The tests are very similar to the quiz questions. Okay, why is this not a function? Not every x was used. B was not used. Other ways of saying that. Not every x was used. You can say something like that. Why is the second one not a function? A was used twice. Equivalent statement, an x was used more than once. And something similar. All of those perfectly good, valid explanations. Okay, let's get to the trickier one. What is F's domain? Question 3. What is the domain of F? This is a trick question. Exactly. 0. Nope, it's not all real numbers. You'd think that was trick. But I actually told you what it was. F is from x to y. So what is the domain of F? It's those 5 numbers. Because I told you, right? F goes from x to y. So that means that the inputs, the valid inputs, are the elements of x. Oh, the answer to 2b was b was not used, or not every x was used. So this is kind of different, you know. I'm not asking you the domain. I'm giving you the domain, and you have to kick back alternate answers. You could have put a big capital X. Right? That set is the domain. Well, what is the target? Big capital Y. What is the image? Now, that's a little bit of a harder question. In order to figure out the image, we need to compute what this is. Okay? So let's go back down to the bottom here. I agree with you. That's the image. But let's do the next problem because that answers the first one, right? So write F as a set. You don't need the F equals. Where does 0 map to? Well, if I plug in 0 here, it's less than or equal to 2, so I wind up with 0. All right, 1 maps to 2. 3, I'm here now. 3 maps to 2. 4, I'm here, maps to 3. And I'll just write here on the side here so I know what I'm doing. F of 0 equals 2 times 0 equals 0. F of 1 equals 2 times 1 equals 2. F of 3 equals 3 minus 1 equals 2. F of 4 equals 4 minus 1 equals 3. Oops, I'm sorry. You're right. F of 2. Because I'm an idiot. Remember that Scott is wrong is often a valid answer. I'll even write that right there. Scott is wrong is often the valid answer. Okay, so now going back, what's our image? Yeah, our image, if we just pick it off, is 0, 2, 3, 4. And I can actually write that 0, 2, 3, 4. Order doesn't matter when it comes to a set. I'll write them in order because it looks nicer. But it actually doesn't matter. Other valid options, you could have said y minus the set 1 if you know set notation for that. It's all the output boundaries. That's the image. Same thing as the range. I don't like the word range because because people confuse it with target. I like image better. But it is range. Range is the same thing. Okay, so those three little part A and part B. How do we feel about that? Let's see. Pulling, multiple choice. Why won't it just leave it like it is? 3, 4, 5. So this is question 3, parts A and B. I so need a TA in this session, don't I? Would 0, 4 be correct? I'm not sure for which part of part A. Oh, you mean the interval 0, 4? Or do you mean the interval 0, 4 actually kind of means a subset of the real numbers. You could have written the intersection of that, right? So you could have written something like this for part A. You could have written something like 0, 4, cap x. That actually would have been correct because this is all real numbers between 0 and 4, including the endpoints, intersected with those real numbers. Now, why would you write this instead of just x? Technically, you actually could have written the number 4 because in the construction of the natural numbers, you could have written the number 5 because in the construction of the natural numbers, the number 5 is 0, 1, 2, 3, 4 as a set. But if you want to, smoke that particular brand of weed, you can check out the discrete class. The last lecture in the discrete class, I actually went over the construction of the natural numbers. So you could have said the number 5 because the number 5 as a set is that. But don't confuse yourself. Don't, ignore that completely if that doesn't make you comfortable. Yeah, that's kind of one of those, yeah, man, let's construct the natural numbers type things. And that's what we're playing with in discrete class. That's fun. I like that class. I like this class too. I love this class. Both of them are fun to teach. I'm lucky. I get the classes that are fun to teach for me. All right, let's draw a little arrow diagram. Wait, I've got spam call coming in on my phone because I had my phone out because I needed the authenticator. So when I draw an arrow diagram, what I want to do is I want to have an X space and a Y space. And this is actually a good habit to get into, is using arrow diagrams to do things. Because they are slick and they give you a little bit more information than, especially with finite things, they often give you, they often reveal information that gets hidden by the other things. All right, so I've got 0 maps to 0, 1 maps to 2, 2 maps to 4, 3 maps to 2, and 4 maps to 3. Does everyone agree on that? One to 5, how do we feel about that little arrow diagram? You don't have to. I would, because we're going to wind up into situations where we've got a u space, a v space, a y prime space, or a dy over dx space. So you might want to get in the habit of just saying where you are. Because when we start dealing with derivatives, we're actually going to have situations where we've got an x space, what we do with composition, we're going to have an x space, a y space, and a z space, z space. And when we deal with derivatives, we're going to wind up with like x space, y prime space, or dy over dx space. And it's kind of a good habit to just get into the habit of labeling them. So you know what you're talking about. It's not required, but it's a good habit. All right. The second one, draw a graph of f. All right. So 0 maps to 0. 1 maps to what? 2. 2 maps to 4. 3 maps to 2. And 4 maps to 3. Okay, how many people connected the dots? Why am I not connecting the dots? That's right. I don't include the numbers between them, right? The domain of this function, right, is the points 0, 1, 2, 3, 4. F of 1/2 is not defined. Right? I mean, you look at this formula and like, oh yeah, I could use 1/2. But f of 1/2 is not defined, right? That's not my domain. This function cannot deal with 1/2. The rule could deal with 1/2, right? If I told it, oh, this is valid for 1/2, okay, the rule will deal with that. But the function can't, because the function's domain is 0, 1, 2, 3, 4. This has, if I say x equals 5, this function goes, I don't know what to do with that. That's not my domain. I deal with 0, 1, 2, 3, 4, right? The function itself is not this rule. The function is this set. The function is this set. That's right. It's not in the functions department. The function is actually this set, not this rule, this set. Okay, how do we feel about that? 1 to 5. So this is the graph. Okay, I'm going to close the poll now. All right, let's move on. What is the sine of pi over 2? Right? It's my northiness, and it's 1. What is the cosine of pi over 2? 0, correct? My eastiness is 0. What is the tangent of pi over 4? 1. Now, I have a question. What is the sine? What is sine pi over 4? Root 2 over 2. No. The perfect pre-calc answer. Root 2 over 2. No. I hate this answer. Can someone tell me where this comes from? No, that is the pre-calc answer. That is the answer that you should be saying at this point in your lives. Can anyone tell me where this comes from? Why is it root 2 over 2? Of course not. This is something you memorize, right? You memorize root 2 over 2. Yeah, it does come from a triangle. Yeah. Connolly proves it. Yes, he's very good at this. Connolly also has this rant, although I think he started to shut up about it in pre-calc because people were yelling at him about, his students not getting the right answer on the automated test. Where does this come from? Now that Connolly is sending me his pre-calc students, I get answers to this that are the correct answer. Yes, Peyton, got it. The correct answer for calc is the square root of 1/2. Now, it is the case that the square root of 1/2 equals 1 over the square root of 2, which equals 1 over root 2 times 1, which equals root 2 over 2. That is correct. But this is the answer we're interested in. And here's why. This answer, the square root of 1/2, begs the question. All right. So my runner has run around this circle to this point right here. This arc length here is pi over 4. That makes this angle here 45 degrees. All right. Now, if I look at this here, this is my eastiness. And this is my northiness. And this is 1. Is everyone on board with that? 1 to 5, how do we feel about that particular thing? Pulling. Multiple choice. Oh. So 1 to 5, how do we feel about that? All right, so I've got an arc length here of pi over 4. And what I want here is the northiness. So if I've gone pi over 4, I've gone halfway to this. What's the circumference of this circle, by the way? I can't spell things. Yeah, it's 2 pi. So that means a quarter of the circle is pi over 2. That's the length of this arc here. And the length of this arc here is pi over 4. That's 1/8 of the circle. So if I've gone 1/8 of the circle, I've gone 1/8 of 360 degrees. That means that angle there is 45. Now, here's something that they didn't tell you in pre-calc, or Connolly may have. Radians are a measure of distance, not of angle. They sub-in, they're equivalent, but they're not the same thing. A radian is this arc length, whereas an angle is this degree. Now, again, there's a perfect correspondence between them, right? So you can call pi over 4 a angle because it's equivalent. But it's not actually the same conceptually. They're slightly different conceptually. So these radians actually refers to a length. It's this radius. It's this times the radius. It's this in terms of the radius. So if the radius here was in terms of yards, if this was 100 yards, this would be pi over 4 times 100 yards. Totally different aside. Now, so what I wind up with is this triangle right here. And this triangle has hypotenuse 1. It has a thing of 45 degrees, and it has a right angle there at the bottom. Now, question, what is this angle here then? If this is 45 plus 90, what do the angles have to add up to? Yeah, the angles have to round up to 180. So it's 180 minus 90 minus 45. And what's left? (45 degrees). That makes this an isosceles triangle. Is that correct? So I have a right triangle that's isosceles. What is the most famous theorem in mathematics? That's right. Most famous theorem in mathematics is that A, if this is A and this is B, it's A squared plus B squared equals C squared. C in this case is 1. But this is an isosceles triangle. That means that this side and this side are equal, correct? That means A and B are equal. So these two things together imply that A squared plus A squared equals 1, which is the same thing as saying 2A squared equals 1, which is the same thing as saying A squared equals 1/2, which is the same thing as saying A equals the square root of 1 over 2. And this is the better answer. Because now the square root of 1/2 begs the question, where did you come from? How do we feel about that, 1 to 5? Why this is better? Why the answer, the square root of 1/2, is actually in some sense better? Right? Because this begs the question, why is it the square root of 1/2? Well, it's the square root of 1/2 because of the kind of, why is it the square root of 1/2? Because of the Pythagorean theorem. And I probably spelled his name incorrectly. So A equals B because the triangle is isosceles. Right? That's this little note right here. The angles are equal, therefore the sides are equal. So that's what I wanted to make was a point about simplification. What I want is the better answer. I don't want root 2 over 2, right? This is something that you memorize. This is something you understand. Memorize, understand. Right? That's boring. Memorization is boring. Understanding is better. Okay. So that's my little rant on why I don't want you to oversimplify in this class. Because I want you to write the answer that tells you where the answer came from. And the judgment for this, you'll get it. You'll start to understand this better, and you'll get exactly what we're looking for later. But this is kind of the start. Okay, I've talked for way too long.